All right, welcome back. So today I want to continue with the MQTT implementation on our ESP32 board. First of all, if you didn't see the last one, that might not be a problem. I only set up the Wi-Fi there. So right now I'm in the state that I have a Wi-Fi connection that's up and running and connected. And from there on, we can start doing some actual MQTT. First of all, let's continue where we left off. We did a cargo run, and what we could see once we flash it, that it says info connected. That was the line that said that the Wi-Fi was connected. And we need to remove that hello task because it's annoying. But from then on, we should have a functioning Wi-Fi stack. So let's get to coding. Okay, so we have a main function. Let's first deal with that hello, because that's pretty annoying, this task. And we remove this one. So we created a stack object. That's a leaked box, so it will be available forever, and it is a MSEnet TCPIP stack. And also we have the DHCP config, so it has an IP number. I passed that to the run network function, where it did all the connection. So it started, this is a little bit useless, and it would check the state. If it's connected, then it won't do much. It will just wait for 5 seconds, and otherwise it will try to connect and then configure and connect. So this I would usually copy paste. I think I used this connection kind of function in like 5 or 6 different projects, and it's always the same. But I thought that because I never really went into it, that this is nice to break it down. So that was last week. This week, let's continue. So we start with a stack that we assume works. So let's create a task for the MQTT. So we create a new file, mqtt.rs. We include that by adding mod. So what do we need to do? Well, let's create a task, and we create an async function. Let's call it send MQTT message. So let's keep it simple. We just want to send a message. For that, we obviously will need to have a stack object, right? So create a stack. That's a stack type. What does it need? I'm not entirely sure. I'm pretty sure it's a static. Wi-Fi SDA device. And finally, do we need anything else for this one? They didn't need that, okay. What does the stack all need? Okay, and that should be a static pointer, I suppose. Okay. And the Wi-Fi SDA device. Let's have a look at the main, because there it just says it. I think the language server has a bit of an issue. Let me restart it. Turn it off and on again. So we need to find the exact type that we get here and then pass that in if the Rust analyzer wakes up. It surprises me that it doesn't well, this one should be the same. So let's use that and get it over with. Okay, import the things. Embassy task. Now we still have the problem that we should not really ever return. So we do loop and let's send a message every 10 seconds. So we do something like this, send message, and then we timer after, let's maybe 5 seconds or something like that. Embassy timer. So how do you send a message in MQTT? First of all, let's add a dependency, and we do let's first have a look at docs.rs, and the one I want to use is Rust MQTT, and that's an embedded friendly client for MQTT. I need to create a client object. There's not a lot of pros here, but it's an async capable driver, so you don't need so you can just use the task as we're used to. Yeah, it doesn't really contain much text, so let's first just get to coding. Cargo add Rust MQTT. Yes, but was it no default features? Because it said it has included standard now, and that's not okay. I'm not sure if we need log or not, but let's leave it here for the time being. So back to our code. So if we were using something with an operating system like just a regular computer or something fancier, then we would have system calls, and then we could make a MQTT client. This is all pseudocode, so TT client, and you could say it should look something like this. So MQTT client new, and then you have a thing MQTT client, and then you say send message, and you say a topic, and you message as bytes or something like that. Doesn't matter. And maybe because it's async, we do a wait. So that would be really nice and really simple. And then honestly, because as you can see, you wouldn't need to bother at all with stacks and Wi-Fi and all that stuff. But we don't have that luxury. We are in bare metal mode, so we need to explain everything. Also, what we tend to use a standard library and an operating system for is to create a degree of abstraction. So the MQTT client is not just for an ESP32, it's for a bunch of different microcontrollers. So you don't want to have hardware specific code in every program. So that's why computers have drivers, right? That you don't glue them one on one. And that's kind of the same here, even though it is not really an operating system, but you do want to have that abstraction. And for that you need things like EmbassyNet and small TCP and all those things that glue it all together. All right, so this is not going to work because this would imply that this client knows how to create a connection. And it obviously doesn't, because it has no idea on which hardware it even is. So we need to give it a TCP stack. Moreover, this client even, let me remove this one because that makes no sense. Let me create a real one. MQTT client. That one. New. And if we have a look, what we put in is a network driver. But the network driver, that is, well, it's barely a driver. It's just something that implements async read and async write. And so that means like just something you can write to and something you can read from. The whole part of connecting somewhere, that's not even in here. So we need to do, what we need to do is first figure out where we want to connect to. For that we'll need to make a DNS query. Then we have an IP number we want to connect to. So we create a TCP connection. Then we connect that to the IP number we found. Then we have a working TCP connection, and we give that to MQTT, and then it can do its thing. It can send messages, subscribe to things, because then it knows what it needs to do. So that's actually quite a few steps before we get to the MQTT part, and that's kind of yeah, the life in embedded engineering, that you have to do a lot of stuff yourself. You, in a normal software sense, wouldn't really need to think about. But it is what it is, and that makes it fun. Moreover, what we need to think about is we need to instantiate this. So let's add this one, spawner.spawn, and it was called this with the stack. And we unwrap that. Probably need to include it, and it's not public, I suppose. Yeah. There is a bracket wrong. That's weird. Let me see. Can I clone it? Is that how it works? I thought it was. Oh man. So let's have a look. I am a little bit confused that I can't pass. Maybe it doesn't need to be mutable. Does that help? I think that helped. So now I have this thing, and now I have the stack, which I'm not using yet. So this thing gets instantiated. Now, bear in mind that at this point here, I spawn these 3 tasks at the exact same moment, so they start at the same time. So when we end up here, that stack kind of exists, but it's very certainly not up yet. So this thing should just hang tight and wait until we have a working connection. So let's check if we have a link. So let's do stack is up or something like that. Is link up. All right. Now let's do, if it's not up, then we wait for, let's say, half a second. Wait. And then we continue. So then we continue in the outer loop. And otherwise we just continue. So now, if we are here, then it probably means that our stack is up and running. What next? Next we need to, let's take a step back and let's talk about what MQTT works like. We talked about it a little bit last episode. And one of the no, that was not what I meant. One of the advantages of MQTT is that there is a broker you connect to, and you can host your own. It's all open source, of course. You can pay for a private one, or you can just have a public one where everybody is free to post whatever within reason. You can get banned, and then you can subscribe to it. And as we are not doing anything remotely important, this is just fine. So here you see which ports we are talking about. I'm not gonna bother with WebSockets or with encryption, so I end up with this one, the most basic version, on port 1883, and an encrypted TCP on this host. So step 1, resolve host. So we had this thing, let host. So how are we going to do that? For that, we need to create a DNS socket. DNS socket, there it is. Also an embassy thing. And what we want to do is create one with a stack, exactly. And now we have a DNS socket, and then we can use that to resolve a query. Get host by name. And now we already have the host, and I'm not sure about this one. The address type, I'm assuming it's enum. Doesn't matter. but it's IPv4 in any case. And then we, of course, we await it, and then I guess unwrap it as well. At IP, something like that. So let's check what type it is. This is IP address. So this is the IP address where we are connecting to. Again, we have an extra problem because DNS queries aren't reliable. It's over UDP. Packets might get lost. So unwrapping it here like this is a bad idea, because yeah, it might work, it might not, and you really never know. So we need to do a sort of try until we succeed, right? So let's make it nice and rusty. So we removed unwrap. Now we have some kind of result of an IP address and an error. And then what we can do is simply say loop. And we try this. And let's assign it result. And then we can say if result, let's unwrap it. So if let OK IP equals equals the result, then we say break with IP. And otherwise we say timer after half a second and await. So this is actually pretty neat, I think, to form it like this. We can condense this a little bit more. So what are we doing here? We keep on trying getting this IP address, and this will loop until it does, and wait every time 500 milliseconds. So now presumably here we have an IP address. So now we can start thinking about creating a TCP socket. So for that we need a TCP client, also EmbassyNet, and we create new. So needs two things: a stack, well, we have that, and it needs TCP client state, and we'll need to make that. So as you can well imagine, that a TCP connection needs some resources, and because in this embedded world libraries don't want to allocate their own memory, because then you might be in a situation where you can't allocate memory at all. It's all kind of assigned at startup. But so you will have to do it yourself. It will say like, yeah, I need some a state object for that, and you need to give it to me, basically. So TCP state. No, TCP client state. State. It needs some things. It doesn't need actual parameters. It's more about that it needs type parameters. 3. N is the number of connections, I think. Is it explained somewhere? No, it isn't. I'm pretty sure it's how many connections we want to support. Let's say 5. kind of silly, 3. And then we need 2 buffers, transmit buffer and receive buffer size. So I really don't know what makes sense in this sense. So let's say something like this. I think for our use case it's fine. So let's see. This needs to be a borrow, and I'm pretty sure a mutable borrow. So this is not mutable, of course. We assign the client, and now we have a client. It's still not connected to anything, right? We still need to do that part. So next step, connect somewhere. TCP client, by the way, pretty sure it needs to be mutable. Dot connect, and we need to connect to a socket address. So that's a TCP destination. So we have IP here, but we need a TCP endpoint. So we need to make that. So a socket address, how do we make a socket address? Let's see, socket address, new IP, we have it on the port, and if you remember, it was port 1883. And all these things, the host and the port, you would probably configure through parameters or something like that, but let's get something that more or less works first. So connected, not sure what we get. A future, so we need to await it, and the result, so we need to unwrap it. And now we have an actual TCP connection. And TCP connection, let me check that, go to definition, is in the embassy crate, and it supports read and write from the embedded async IO. And that's basically all what the MQTT client wanted. Something that implements read and implements write. So let's comment undisable this one and see what we need. So this is supposed to be, let's connect TCP connection, better name, and we pass it here. What's next? A buffer. Let's look up what it needs. Just a slice and length for both sending and receiving, I suppose. Okay, so that's something we can do. First, what happened? Let's create those buffers. Let send buffer is that's like 0, and then I don't know what's a decent quantity. Should it be smaller than the TCP buffer? I don't know. Let's make it the same, and then I need to give it a type, I suppose. U8. We have a send buffer, we have a receive buffer, and we let's make a constant anyway, because this is getting ugly. Const buffer size usize. Because I starting to repeat myself a lot of times. And then it was send buffer with that length. And I guess it's a mutable borrow. Okay, so that largely works. Yeah, there are way more efficient ways of doing that, but for now this is okay. What's the final one we need to give it? It's a client config. Let's make one. Yeah, new version and an RNG. Okay, so two things. That this is probably an enumerator, which MQTT. Let's take the newer one. V5 and an RNG implementation. Not sure how important it is when you don't use TLS, but there is a very simple one, and it's called the counting RNG. And how does that thing work? Oh, you just create it with a seed number and it counts from there. It matters not a lot. And now we have the config, and then we can pass it in here. What's wrong? It needs to have a type defined or turbo fidget for the max properties. Okay, let's give it a type then. And okay, so we say 5 properties, something like that. That's good. And then we need to make these things mutable. Okay, I think we have appeased the compiler, and we have a MQTT client we can use. What can we do with MQTT client? I guess connect to broker. That will result in nothing if it works, and otherwise with some reason. And send message with the topic, a message, a quality of service, and a retain. I'll get to the details of that one, but let's go. So I guess this one needs to be mutable as well. Connect to broker, await, and wrap. So now we should be connected. Next up, sending a message. MQTT client send message. Topic name. So let's say ESP32 test topic with a message. The message is a byte array, so it can be any bytes. You can also use some binary encoding if you want, but right now let's say let's create a message. I will just make something simple. I create mutable integer counter. We start at 0, and every time we say we increment that counter. Yeah, what's wrong here? Yeah, let's say we format it. We format the string. Hello there, and a number, and that number is our counter. So we can distinguish which message we're looking at, because that might be important. Quality of service. Let's see. You can use several. Invalid, which I guess won't work. There's quality of service 0, 1, and 2. 0 is just fire and forget, so either it will work or it doesn't. It doesn't wait for anything. Quality of service 1 is that it will keep on trying to send it until it gets an acknowledgement. So it can mean that if the acknowledgement got lost, that it will send more than once. So if your protocol really doesn't want that to happen, you can use quality of service 2. That will get that exactly right. So the first one is just what's it called? At most once. So it might arrive, it might not, but it will not be repeated. The second one is at least once, so it will definitely keep trying until it works, but it might send duplicates. And the third one is exactly once, and then you will be sure that it won't be duplicated and that it will keep on trying. But the downside is that's just more work, and especially on low power devices that might be a problem. So if you are sending, I don't know, some measurement, some temperature, I don't know, and it takes really long, at some point there's not much point in keeping on trying. It's better just to move on and accept that you missed that measurement. Let's put it on quality of service 1. It doesn't matter much, I think, right now. How do we get this ugly thing out of here? I thought you can replace with the use. I don't know why that I don't see it. And anyway, last one, retain. Does it need to be retained on the server? I think. I don't know if it even supports that, but false. Await and unwrap, I suppose. What's wrong here? Yeah, of course, this is string. I say as bytes. Why doesn't it work? Yeah. Okay. So this thing, I guess, doesn't need to be mutable. Let's write something that we can see iteration completed, something like that, that we can see if it's doing anything. Secondly, we need to see if the message arrives. So let's MQTT X, I think, yeah. So you can use a sort of let me clear this one up. Let me delete this one for a moment and start all over. So we create a new connection to this one, and you don't need to use a GUI. There are some pretty decent command line ones as well, and yeah, whatever, it doesn't do anything special. We connect there. It has a client ID. I'm not super bothered by that either way, and all kind of details. Let's see if I can connect. All right, so we are going to publish to the ESP32 test topic. So we create a new subscription with that topic name. We can match it, I don't think it matters. And we confirm. So right now we are listening, and if someone would write to that topic, we would see it. We can write ourselves to the topic. Let's say, hello, spell it right. And then we see it both because we send it and because we received it, because we are registered, subscribed to that topic. So now let's see if our microcontroller is up for the job. It's connected, and here you go. Look at that. So it says hello there 0, hello there 1, etc. So I think I'm gonna leave it at that with this one, because it's already nearly 45 minutes. But yeah, this is kind of nice, right? We cut a whole lot of corners. We unwrap all over the place. We don't really deal with anything very gracefully. A lot of cases when something doesn't work, we should just make sure that we continue the loop so it reconnects, if that's what we want to do. And now the controller isn't doing anything else except this one thing, so we don't really even need a whole async runtime if this is all we want to do. But often we do want to do more. Next up, we're gonna also receive messages. We can do both up to a point, and we're gonna figure out how to organize the code a little bit, because if I want to, I don't know, like get some measurement from some device, I don't really want to do it in the middle of this task, because then it's kind of like programming C then, like that we end up with one huge loop and we do everything in there. And because the Rust is actually making that a little bit harder otherwise, because this client object is something you can't really move around. You can't really transfer ownership to it because so much stuff sticks to it, right? You have TCP connection, that one sticks to the TCP client, and that sticks to the stack and everything. So it's kind of impossible with all those static things to pass it around. So we'll figure that one out. We can pick up some. We can use our trusty channels again. We are using from Embassy Sync. But we'll get to that. But for now, we have a nice thing that sends things, and yeah, that's interesting. Did you see that? So I'm not sure how that's possible, but it was here at 8 and then it was at 30, which is, I think it's the client who dropped those, because it kept on counting. It has quality of service 1. So I think somehow when you defocus, maybe it misses things. But that's interesting, right? That you need to think about those things, because I'm pretty sure that the controller kept on sending because it wasn't doing anything. But yeah, that's all for today. Please leave a like if you have time, and next time we'll make this thing a little bit nicer. Yeah, see you soon. Keep on playing with embedded, and if you have questions or ideas, leave a comment or hit me up on LinkedIn. It's linked somewhere in the channel, and see you soon. Bye.